and it's going to be a little bit harder to see the excluded values, but we've learned what to do if we have something like x squared minus 2x minus 15 in the denominator. Okay, if we can't easily tell, like we could in the last example, what x can't be that makes the denominator go to 0, then we could factor the trinomial. And what is it going to factor into? X minus 5, somebody said, and x plus 3. Then we can look at each factor, and this factor, what makes this factor go to 0? Positive 5. So x can't be positive 5, and in this factor, x cannot be negative 3. So now I have two values that cannot be in my domain. So you're going to say the domain goes from negative infinity all the way up to the smallest excluded value, which is negative 3, parentheses, because x can't be negative 3, union, and then parentheses again, negative 3, all the way up to the larger excluded value, which is 5, parentheses, union, parentheses, and then finally 5 all the way to infinity. So our domain includes everything. If we're having to list all the x's, we have to list all the x's except for negative 3 and positive 5. And that's how we would list all the x's except for negative 3 and positive 5. Questions about 7. All right, let's look at number 11. Equations are going to start to get a little bit more difficult. So I picked number 11 to show you that if your function had two fractions, I don't want you to think that you actually have to combine those two fractions. You can just look at their two denominators. Okay? So they are different. Let's look at this denominator. Will it factor? Okay, a couple people are telling me the factors, and a couple people are saying it will not factor. X squared plus 1 will not factor. Okay, will not factor. X squared minus 1 will. That's the difference of squares. How does it factor? X plus 1 and x minus 1. Okay, now let's go back to this first factor. What can you square and add to 1 that will give you a 0? What can you square and add to 1 that will give you 0? Negative 1? What's negative 1 times negative 1? 1, and what's 1 plus 1? 2. So negative 1 squared plus 1 is not 0. What would make that first denominator 0? 0. 0 squared is 0, and 0 plus 1 is 1. Can you square anything and add it to 1 and the denominator go to 0? No. So there's no excluded values from that first denominator. But what's the smallest value that you can get when you square something? 0. So the smallest value that I could possibly get would be 0 squared. That would give me 0. But 0 plus 1 would give me a 1. So my only excluded values are what? Negative 1 and 1. And they come from that second denominator. Okay? If x is 1 and I square it and I subtract 1, I get 0 in the denominator. If x is negative 1 and I square it and I subtract 1, I get 0 in the denominator. So positive 1 and negative 1 would be the excluded values. So then your domain would go from negative infinity to negative 1, parentheses, union, parentheses, negative 1 to positive 1, parentheses, union, parentheses, 1 to infinity. All right, questions? All right, they can get even a little bit harder than that. Let's look at 15. We have f of x is equal to 1 over 4 over x minus 1 minus 2. So what I need you to see in this problem is I have a little fraction inside of a big fraction. So I actually have two fractions that I have to look at. So let's look at the little fraction in the yellow box. What can x not be in the little fraction in the yellow box? X can't be 1 there. Okay. And then let's look at the denominator of the big fraction, the one in the green box. Okay, so the one in the green box is 4 minus, or 4 over x minus 1 minus 2. Y'all agree that's what's in the denominator of the big fraction? Okay, and we don't want that value to be equal to 0. Now, can you, in your mind, figure out what x would be? Somebody says 3. Think about that. If x is 3, on the bottom you have 3 minus 1, which is 2. Then you have 4 divided by 2, which is 2. And then you have 2 minus 2, which gives you a big fat 0. Okay? So if you can't see that x cannot be 3, you could set this equal to what? You could set it equal to 0, and you could just solve for x, and that would tell you what value of x makes that denominator go to 0. You can just see what x would be. So x can't be 1, and x cannot be 3. So the domain's going to go from negative infinity to what? 1 parentheses, union, parentheses, 1 to 3, parentheses, union, parentheses, and then finally 3 to positive infinity. Alright, so are you starting in your mind to say, okay, if there's 2 excluded values, how many intervals will I have? 3. If there's only 1 excluded value, then I'll have 2 intervals. Does that make sense? Okay, you just need to make sure that you list every single real number except for the excluded values, and it needs to be in order from the smallest to the largest. Alright, let's look at 19. Still finding the domain here. And now they're going to throw in a square root. Okay? So anytime you have a square root, no matter whether it's in the top or whether it is in the bottom, okay? It doesn't matter where the square root is. We do not want any imaginary numbers. Those are not real numbers, okay? So it doesn't matter here that the square root's in the bottom. It could actually be in the top. Anytime you have a square root, you have to take what's under your square root, and you have to make sure that it is not negative. So if something is not negative, it must be greater than or equal to 0. If something is not negative, it must always be greater than or equal to 0. So anytime you have something under the square root, whether it's in the top or the bottom, you take what's under the square root, you set it greater than or equal to 0, because that's what x has to be to make sure we don't have any imaginary numbers. Once you solve here, it says our x's must be greater than or equal to, I don't know why I put 0, greater than or equal to 3. Okay? Now that's what the x's must be in order not to have any negatives underneath my square root, which would produce negative numbers. Negatives under my square root. Okay, now also know that this x cannot be what value? It can't be a 3. So let's think about this. This statement says x must be greater than or equal to 3, or we'll have what kind of numbers? Imaginary. Then I have x can't be 3. Why can x not be 3? It would put a square root of 0 in the bottom, which is 0, and 1 divided by 0 is undefined. So I've got to make sure my domain is greater than or equal to 3, but I also have to make sure that I do not include 3. So if I think about both of these, that means that my domain is actually just x is greater than 3. I have to take that equal to away, Alright? I have to take the equal to away because if x is equal to 3, it makes my function undefined. So you've got to make both of those things true. You've got to make sure everything's greater than or equal to 3, and you've got to make sure that x can't be 3. So how do we write x is greater than 3 in interval notation? Parentheses 3 to positive infinity. So just saying, if we looked at the graph, just so you could see, and we're not graphing here, but you know your graph might look something like this. And it was asking you for the domain. If we actually turn that back into a graph, the graph of the equation, your graph would be our x's start at 3. They don't include 3 because there's an open circle. And then the x's get larger than that. So we can tell what the graph is going to look like. Okay, we can tell about the domain just by looking at the equation without graphing it. Okay, but just to go back to something that you've done before. Alright, are we going to change directions? There's a whole bunch of problems that say find the domain. We did number 19. 23 still says find the domain. Let's do one more find the domain. Again, y'all are doing every other odd. So again, anytime you see a square root, no matter whether it's in the top or whether it's in the bottom, we don't want any imaginary numbers because they can't be in our domain. Our domain are just real numbers. So we've got to take what is under the square root and we've got to make sure that it is not negative. How do we make sure that it's not negative? Make sure that it is greater than or equal to 0. So 24 minus 2x must be greater than or equal to 0. If it's not, then I'm going to get imaginary numbers. I'm going to solve. I'm going to get negative 2x is greater than or equal to negative 24. I'm going to divide both sides by negative 2, which is going to flip my inequality sign, and I'm going to find out that my x's must be what? Less than or equal to 12. And how do I write all x is less than or equal to 12 in interval notation? Negative infinity all the way to positive 12, parentheses or bracket. Bracket. Is there anything in this problem that would make the function undefined? Anything in this problem that would make the function undefined? Yes or no? Molly says no. She's right. Why is there not anything in this problem that would make the function undefined? There's something that would give me imaginary numbers, but why is there nothing that will make the function undefined? You have an understood 1 in the denominator, which also means you don't have any variables in the denominator. Okay, that's where undefined values come from. That's where excluded values come from. You don't have any x's in the denominator here. All right, let's look at one more domain. 27. So again, I want you to really understand what we're doing here. So now I've kind of taught you everything. I want y'all to walk me through 27. The directions are going to say find the domain.
X can't be 5.
Okay, I agree with that. X cannot be 5 because if x is 5, I'll have a 0 in the denominator and that function's undefined when x is 5. X minus 2, it has to be greater than or equal to 0 or I will get imaginary numbers, and I can't have imaginary numbers. Domain are always real numbers. So that means x has to be greater than or equal to 2. Now you have to consider both of these. Okay, when you write your domain cannot have the number 5 in it because it makes the function undefined. And in your domain, your x's must be greater than or equal to 2. Okay? So, start from the left on your domain. Can I have x's at negative infinity?
Yes.
You can't because
Can I have x's at negative infinity? No. What's the smallest x I can have?
2.
2. Okay? Can I have 2?
Yes.
Yep. So we'll need a bracket. Alright? Alright. All the way up to 5. I can't have 5. So to show that I can't have 5, I'm going to use a parentheses, and then I'm going to have to use union. Does that answer your question, Naomi? So your x's must be greater than or equal to greater than or equal to 2, and you cannot have a 5. If you get confused, I'm a visual person, and what I do is I put my numbers on a number line, and I know at 5 the circle is going to be open. This is just another way, if this makes more sense to you. At 5 the circle has to be open, showing we can't have a 5. And then I'm going to do x's are greater than or equal to 2. So I would have a bracket or a closed circle. You could do a closed circle there if that makes more sense to you. Closed circle, and then I'm going to shade to the right. Why am I shading to the right? It's greater than. I have to skip over the 5 though. And that gives me a visual of what my x's would look like. You could actually just put it on the x-axis. You could just do one number line, and that just represents your x's. And then you would actually write that in interval notation. So if it helps you to draw a number line, if you start to get kind of confused like 27 is, draw a number line. Some of y'all can see it. Some of you need to draw it. All right, any questions about domains? All right, the next set of directions are asking you to do 3 different things. They're asking you to find f plus g of x, or just f plus g. They're asking you to find f minus g. They're asking you to find f dot g. And they're asking you to find f divided by g. So it's really like 4 little problems in one. So let's take a look at number 31. This is not difficult. You've actually done this before, but you just have not done it with function notation. So they're going to give you an f of x equation, and they're going to give you a g of x equation. So this part is given. They're going to give you 2 equations. Your directions say I want you to do 4 operations. I want you to add these 2 functions and get an answer. I want you to subtract the 2 functions and get an answer. I want you to multiply the 2 functions and get an answer. And I want you to divide. It's 4 separate problems. So let's do the first one. Let's add these 2 functions. So if we're adding, we just get 2x plus 3 plus x minus 1. It's always a good idea to use parentheses because when you're subtracting, it's going to matter. All right? But as long as we're adding, we can drop the parentheses and just combine like terms. So we're just adding these 2 functions together. That means the signs don't change if we're adding, and we combine like terms. So we get 3x plus 2. So when we add the 2 functions, we get 3x plus 2. They're also going to ask you for the domain of your answer. So 3x plus 2. Any x's in the denominator? No. Any x's underneath square roots? No. So your domain would go from negative infinity all the way to positive infinity. I'll make the next one a little bit bigger. That's probably not big enough. Okay, the next thing that we're going to do is we're going to subtract the 2 functions. So that means we're going to have 2x plus 3 in parentheses minus x minus 1 in parentheses. Which set of parentheses can we drop and not change anything? Okay, we can drop the first set of parentheses, but the second set of parentheses, since we're subtracting, you'll have to distribute a negative 1. That's going to give you a negative x plus 1, and then you can combine like terms. 2x minus x is x plus 3, and plus 1 is plus 4. So that's what you get when you subtract the two functions. You get x plus 4. Any x's in the denominator? Any x's under square roots? No, so your domain would be from negative infinity to positive infinity. Then they're going to ask you to multiply the two functions. Again, you know how to add, you know how to subtract, you know how to multiply, and you know how to divide. It's just a different type of notation. So we're going to multiply now. And they actually have f and g just side by side. That means f times g. So we're going to multiply the two functions. So that's 2x plus 3 times x minus 1. Do we have any shortcuts like square, double square here? No, these are just two different binomials, so we'll just have to distribute it out. 2x times x is 2x squared. 2x times negative 1 is negative 2x. 3 times x is positive 3x. 3 times negative 1 is negative 3. Combine like terms, and f times g would give us 2x squared plus x minus 3. And our domain is negative infinity to positive infinity because there are no x's in the denominator and there are no x's underneath square roots. Alright, and then the last thing is they're asking you to do f divided by g. Yes?
Would you factor the multiply?
No, they're asking you to multiply. So factoring would be not multiplying, it would be dividing. So if they're asking you to multiply, it's already factored. They're wanting you to multiply the two factors together. F, G means multiply those together. So don't go back to factor, because if you do, you'll go back to the original problem. Alright, if we're dividing, we have divided by 4. We have divided before. So we just take f of x, which is the 2x plus 3, and we divide that by x minus 1. Remember, the only thing that could simplify is if you have exactly the same binomial in the top as you do in the bottom, then you could cancel those. But I have a 2x plus 3 in the top, and I do not have a 2x plus 3 in the bottom. I have an x minus 1. So there's nothing actually that cancels here. And so when you do your dividing part, you'll just see if anything will simplify. If it won't, then that's the answer. So that's actually f divided by g because nothing cancels or simplifies. And the domain this time is not going to be negative infinity to positive infinity because I do have an excluded value. What can x not be? X cannot be a 1. So my domain is going to go from negative infinity to 1, parentheses, union, parentheses, 1 to infinity. Alright, you know they probably get harder than this. So we'll pick one that's a little bit harder. We'll pick one that's got a square root in it. Okay. So we'll pick 39. So 39 gives us f of x is the square root of x, and g of x is x minus 4. So again, your directions are going to tell you to add the functions, subtract the functions, multiply the functions, and divide the functions. Alright, so if we are adding, that's going to give us the square root of x plus x minus 4. And when we're adding, we can just drop the parentheses and combine like terms. But guess what? There are no like terms. So you just write square root of x plus x minus 4. If you're adding, drop the parentheses, combine like terms, that's your sum. Alright, are there any x's in the denominator? No. Are there any x's underneath square roots? Yes, so that one little x that's under your square root must be greater than or equal to 0. That's the only thing that affects your domain. Okay, you don't have any excluded values, so your domain is going to be bracket 0 to positive infinity. You must have x's that are greater than or equal to 0. That means bracket 0 to infinity, or you'll get imaginary numbers. when we subtract the two functions, again, just remember to keep that second function in parentheses, because you're going to be subtracting x minus 4, meaning you'll have to distribute a -1. So you're going to get square root of x minus an x plus a 4. Square root of x minus x plus 4, none of those are like terms. So that would actually be f minus g. And I have the same situation here as I did in f plus g. I have an x underneath the square root, so we can just steal our domain from the sum, and our domain is going to be bracket 0 to infinity. Questions about f minus g? Alright, f times g. So we're going to have square root of x times x minus 4. So we can actually multiply this out. Square root of x times x, you got to keep the x on the outside, and you'll just kind of squish those two terms together. So that's written as x square root of x. And then square root of x times -4 will be written minus 4 square root of x. Again, you're just multiplying and you're combining like terms. Y'all have any, we have any like terms here? Alright, this is an acceptable answer. Does anybody want to, no, let's not do that. Let's not factor. That's what Cameron was thinking. That just takes us right back to where we, not that that was wrong, Cameron. We do have a tendency to want to factor. We could factor out the square root of x, but didn't that take us right back where we were? Alright, that answer's fine. Alright, how about our domain? We're going to be the same. We still have a square root of x. So it's bracket 0 to infinity. Alright, and then let's do f divided by g, and we'll call it a day. So f of x was square root of x. And g of x was x minus 4. Can you simplify the square root of x over x minus 4? No, got to have the same binomial in the top and the bottom to cancel or simplify your fraction. So this is the answer, but the domain will change here. Okay? So because x is under the square root, we know that x has got to be greater than or equal to 0, and we have an x in the denominator, and we know that x cannot be what value? 4. So how do I write all real numbers that are greater than or equal to 0 and not a 4? Bracket. Does that make sense? Okay. Remember, your homework is every other odd. If you want to go ahead and write it down, it's page 279. It's in that top drawer over there. Your homework is page 279. And y'all are doing 1 through 45, every other odd. E-O-O. Every other odd. 1 through 45, every other